All right, everyone, this is your 6.4 extra practice. Okay, in the beginning, all they want you to do is classify the parallelogram. Now, it says explain your reasoning. Don't worry about that, okay? What we're going to look at mostly is just naming them using, the tools that we knew or we learned yesterday. Okay, so remember, your parallelograms as of right now, we have a rhombus, we have a rectangle, and we have a square. Okay? Now remember, your rhombus had 4 congruent sides. Rectangle had 4 right angles. And your square had both. Okay, another thing to remember about the rhombus was the diagonals bisect each other. Okay, so what we see here in number 1 actually is your diagonals being cut in half. So this must be a rhombus. The other reason you know it's a rhombus is because the interior angle is 90. Okay, remember those diagonals are perpendicular. They bisect and they're perpendicular. Okay. For number 2, you have congruent sides and you have 190-degree angle. Well, that means that all 4 are going to be 90 in this case, and that means that all 4 sides are congruent. This is your square. For number 3, you know that all 4 are going to be 90 degrees, and that's the only information we have. So this is a rectangle. For number 4, well, if we have 2 sides congruent, that means that all 4 are congruent. That's your rhombus. Okay, for number 5, we have diagonals bisecting each other. We know nothing about the sides. Okay. But if we remember, in your rectangle, your diagonals are congruent. Since these all have 1 tick mark apiece, instead of in our other example where we had 1 and 1 and 2 and 2, we know that this is a rectangle. Okay, and for number 6, again here we have your diagonals being cut in half, so our diagonals are congruent. We have a center of 90 degrees. Okay, again, this is a rhombus. Now, this is your tree of quadrilaterals, okay? Now, if you look at the top, we have 4-sided figures, which are quadrilaterals. So fill that in. 4-sided figure. That's all I'm going to write here. Now, your quadrilaterals branch off into 2 different directions, okay? The first one is going to be your parallelograms. And on the other side, you have your trapezoid. Now, parallelogram has 2 pairs of parallel sides. Your trapezoid only has 1 pair of parallel sides. Oops, let me use the symbol because that's never going to fit. 1 pair of parallel sides. If you notice here, your parallels are on the top and the bottom, but on a parallelogram you have them on the sides and on the top and the bottom. So there's your 2 pairs in comparison to your 1 pair. Now your parallelograms split. These are what we learned yesterday. You have your rectangle and you have your rhombus. And remember, a rectangle has 4 90-degree angles. So go ahead and draw your boxes in all the corners. Your rhombus has 4 congruent sides. So go ahead and mark your congruent sides. Now the 2 of these things together create a square, which is 4 right angles and 4 equal sides. So this is your tree for quadrilaterals. That's actually going to help you here. If a quadrilateral is a rectangle, then it is a parallelogram. Well, rectangles are below the parallelogram tree, so that is true. If a quadrilateral is a parallelogram, then it is a rhombus. Well, under parallelograms, I see 1, I see 2, I see 3 different choices. They don't have to be a rhombus, okay? It could be a square. It could be a rectangle. All right, so this is not true. This is false. If a quadrilateral is a square, then it is a rhombus. Well, remember we talked about yesterday in class that a square, let me change the color. A square is a rectangle, a square is a rhombus, and in turn, that means it's a parallelogram and also a quadrilateral. So a square is all of those things except a trapezoid. So this is true. If a quadrilateral is a rectangle, then it is a rhombus. Well, take a look. Again, I'm going to change the color here so we can analyze a little bit. Let me get rid of our square lines. Okay, so the question is that if it's a rectangle, then it must be a rhombus. Well, that's not the way the tree works. The rectangle is a parallelogram, which is a quadrilateral. The arrow never goes from rectangle to rhombus, so this is false. And if a rhombus is a square, then it is a rectangle. Well, this is just totally false. Sorry, guys. Totally false. Classify the special quadrilateral, then find the values of x and y. Well, we have 4 equal sides, and we have 4 90-degree angles. So we know that this is a square. Now, the way I look at this is I see a variable y and a variable y. Then I look at the other 2 sides, I see a variable x and a variable x. All of these have exactly 1 tick mark, which means that they are all congruent. So I'm going to set the y equations equal to each other. So 5y plus 1 equals 2y plus 4. But what I'm also going to do is I'm also going to set, and let me change this to blue, the x equations equal to each other. So 5x minus 4 equals 3x. And we're going to solve for x and for y. So let's do our y values first. I generally say to subtract or move the smaller coefficient, so 2y is smaller than 5y. 5y minus 2y is 3y plus 1 equals 4. I'm going to subtract 1 on both sides, and my 1's cancel. 3y equals 3, and if we divide both sides by 3, 3 divided by 3 is 1. So y equals 1. Now, if you go to solve the blue, if you follow my general rule of moving the smaller one over, well, if I subtract 3x here, then there's nothing left on the right-hand side, so we cannot do that. We could, but it would be a little longer to solve. I'm going to subtract 5x on both sides, and we're just going to have to deal with negative values for this equation. Negative 4 equals negative 2x, because 3 minus 5 is negative 2. Divide both sides by a negative 2, and we get x equals a negative divided by a negative makes a positive. X equals 2. Okay. Next example. Now, we have 2 angles, and then we have 2 sides. Okay, our sides are congruent, but our angles are not congruent. Those are consecutive, so they're going to be supplementary. So we get 2x minus 1 plus 127, so I took my 2 angles, and they need to equal 180 degrees. 2x plus 127 minus 1 makes 126, which equals 180. I'm going to subtract 126 on both sides, and 2x equals 180 minus 126 is 54. Divide both sides by 2, and x equals 54 divided by 2 is 27. Now, if I go to solve for my green, my sides, we get 6y minus 5 equals 3y plus 7. Well, like I always say, I like to move the smaller one over when applicable. 6 minus 3 is 3y minus 5 equals 7. I'm going to add 5 on both sides, and 3y equals 12. Divide both sides by 3, and y equals 12 divided by 3 is 4. Okay. The diagonals of rhombus PQRS intersect at T. Given that the measure of angle RPS is 30, which they show in the picture, and the length of side RT is 6, find the indicated measures. The measure of QPR, so I'm just going to point these out. The measure of QPR is this tiny angle here. The measure of QTP, and let's do that in blue, I guess, is this angle right here. And side RP, which I guess we can do in purple, is this side right here. So looking at the image, we should notice that the measure of QTP, this angle here, is in the center. Well, yesterday we said that every angle in the center of a rhombus with diagonals is 90 degrees. So the measure of QTP is 90. We also said yesterday that the measure of any corner angle in a rhombus is bisected by its diagonal. So if one side is 30 degrees, then the other side also must be 30 degrees. And the length of RP, well, we have our diagonal, right? They're bisecting each other. So if one half of this side is 6, the other must also be 6. The diagonals of rectangle W, X, Y, and Z intersect at P. Now remember, the key word here is that they said it is a rectangle. Given that the measure of angle YXZ, which is right here, hold on, is 50, which is this angle right here, and the length of XZ is 12. XZ is 12. Find the indicated measures below. So the angle WXZ is this angle right here. But if you remember, rectangles have 90 degrees. So if one side is 50, well, 90 minus 50 makes 40. So this side must be 40 degrees. The measure of angle WPX, well, WPX is right here. So let's cycle back to this in a second. The length of PY, well, PY is this little piece right here, and it's half of the length of this entire line. Well, we said yesterday, rectangles, their diagonals are congruent. So if the length of XZ is 12, well, what is half of 12? That would be 6. So the length of PY is 6. So I'm going to erase everything in this image to clear it up. We know that we have 40 here. Alternate interior angles tell me that this is 40, that this is 50. Okay, and what else does it tell me? That again, we have a 40, a 50, a 50, and a 40. Now, WP and X is this piece right here. Well, if this is a triangle and 50 plus 40 is 90, then this missing piece must be 90 degrees. The diagonal of square DEFG, so this time we have a square, intersects at H. Given that EH equals 5, find the indicated measures. Well, we know since this is a square, all four sides are congruent. We know that all the angles are 90 degrees. We also know that the diagonals create 90 degrees in the center, and the diagonals are congruent to each other. A lot going on in terms of marking in this picture. So since one piece is 5, that means the length of all your diagonals are 5. Okay, so the measure of GHF. Well, GHF is right here in the center, which we said, or marked, as 90 degrees. The measure of angle DGF, D to G to F, is another 90 degree angle. HF, well, let's see. That's a side, and H is the center, to F is the outside. We said that was 5. And DE is the length of one of the sides. Well, let's see. Go ahead and cross this one out because I did not teach you guys this rule yet. All right. So there you have it. Make sure if you're missing anything, if you don't understand, this tree is very helpful. So if you can save this page to reference later, that would be good. Okay. We're going to do much more practice like this tomorrow, especially with ones like this, okay, where you have to solve given the picture and given the equations for the sides and the angles. All right, these are really the ones that we're going to work on the next few days. Okay, again, we need to remember those rules. So if you do not remember these rules, two pairs of parallel sides, right, and these rules that we marked over here for rhombus, for rectangle, for square, please go back to 6.4, the actual lesson itself from yesterday. And that date was 4/19. Okay, so go back to your work from 4/19 and really make sure you understand and know the different theorems that we wrote down in that lesson. Okay, and again, feel free to ask me any questions if you are unsure. Thanks for watching.